So in this video we're going to revisit spanning sets in terms of general vector spaces. So in a previous homework, I think it was homework 14, you were given this definition of a spanning set. We said let u sub 1 through u sub n be vectors in a vector space V. If every vector little v in vector space V can be expressed as a linear combination of that set of n vectors, then we say that that set of n vectors spans V. In other words, every vector in V can be built from that set of vectors as a linear combination. And in the previous homework, previous videos, we specifically looked at R2 and we looked at R3. And if you recall, what we said was if we have the set of vectors in R2 given by 1, 0, and 0, 1, that this set of vectors formed a spanning set for R2 because any generic vector in R2 that has the form x sub 1, x sub 2 can easily be expressed as a linear combination of these two vectors in this fashion. We can go x sub 1 times the vector 1, 0 plus x sub 2 times the vector 0, 1, and indeed that will add up to the vector x sub 1 comma x sub 2. So this is a set of vectors that spans R2, and for R3 we looked at the set of vectors 1, 0, 0, 0, 1, 0, 0, 0, 1, and we identified that this set of three vectors completely spans R3 because if we have a generic vector in R3, x sub 1, x sub 2, x sub 3, we can easily express this vector as a linear combination of these three vectors by in this fashion. X sub 1, x sub 2, x sub 3 is going to equal x sub 1 times the vector 1, 0, 0 plus x sub 2 times the vector 0, 1, 0 plus x sub 3 times the vector 0, 0, 1. So we can express any vector in R3 as a linear combination of these three vectors. But we've introduced general vector spaces now. And so for example, we have shown that the set of all 2 by 2 matrices forms a vector space. So a question would be then, what is a spanning set? What is a possible spanning set for M22, the set of all 2 by 2 matrices? So if we have a generic 2 by 2 matrix, let's call them A, B, C, D, here's a possible spanning set. We could say, let's take the matrix 1, 0, 0, 0, take the matrix 0, 1, 0, 0, take the matrix 0, 0, 1, 0, and then take the matrix 0, 0, 0, 1. And then the question would be, does this set of 4 matrices form a spanning set? Form a spanning set for M22. In other words, can every matrix in M22 be expressed as a linear combination of these? And they can easily be expressed by doing this. A times the matrix 1, 0, 0, 0 plus the B times the matrix 0, 1, 0, 0 plus C times the matrix 0, 0, C's in this position, so we'll use 1, 0 plus, and finally D, which is in this bottom corner position, could be multiplied by 0, 0, 0, 1. And it should be clear that if we take this sum, using our definitions of scalar multiplication for matrices and matrix addition, that will get this matrix back. So this is a set that spans M22. We've also shown that the set of all polynomials of degree less than or equal to n forms a vector space. So we could look at a specific vector space, maybe the polynomials of degree less than or equal to 2. So polynomials of degree less than or equal to 2, what do those look like generically? They look like this: ax squared plus bx plus c. And a question would be, what is a spanning set of polynomials for for the set of polynomials of degree less than or equal to 2. So an example would be, let's take the vector x squared, take the vector x, and the vector 1. So this set of 3 vectors, remember, these are vectors because we're in a vector space, and so we call the elements in a vector space vectors, even if we're not accustomed to calling them that. These 2 by 2 matrices can also be called vectors in the vector space M22. So if we take these 3 vectors in the vector space of polynomials of degree less than or equal to 2, we can describe every arbitrary polynomial using them. We can do a times the vector x squared plus b times the vector x plus c times the vector 1, and clearly ax squared plus bx plus c is a linear has been written as a linear combination of those 3 vectors. So the vector set x squared, x, and 1 forms a spanning set for the polynomials of degree less than or equal to 2.